All right, I think we are live. Might take a second to start going here. All right, awesome. Welcome everyone uh, to our stress test. We are really excited to kind of show what we've been working on over the past few years, and obviously we've done some testing internally and things like that. But this is the first time for everyone on the team that we've actually made this public. So it's a very big moment for us. On stream is obviously myself, CEO of Keeta, and then Roy Keene, our CTO. Um, we have a handful of people behind the scenes that are helping us make this happen, both internally on the Keeta team as well as um, on with our partners. So I appreciate everyone that is tuning in and supporting us as we hopefully make history. Roy, do you want to introduce yourself?
Sure. I'm Roy. I'm the CEO of Keeta. I've been working at Keeta on this project for a few years now, and so yeah, we released some videos of a previous stress test we did a couple of years ago, um, just to validate that the system scales up. But this will be the first time we've done a live stream, I think.
Definitely, it's definitely a little nervous for me, but I know uh, we've tested a lot. So, um, do you want to talk through kind of how the test is going to work and explain kind of what we're doing right now with the ramp up?
Yeah, so in order to generate the traffic, we need to generate a bunch of blocks and then reach consensus on those blocks. So that's more work than just a single computer can do. So we have that distributed out to several thousand systems. So we'll be from several thousand different systems requesting the votes and blocks on on those blocks that are generated for a few different thousand accounts. I don't remember. I don't know the exact numbers because it's just based on how much we need to reach the target. So we're just going to continuously add more and more load and ramp up the TPS and reach consensus, distribute out the blocks, go through the voting process, which it's described more in detail and we've talked about it before, but it's a two-phase voting process um, where we send out a temporary vote, which is a 5-minute vote to reach quorum before getting a permanent vote, and yeah, so then we can actually send out the votes with the quorum attached, and everybody can then accept those. So that's going to be kind of what the test is and how we achieve that. So we'll also be processing this on 30,000 different computers. So it's not like just because everything can be done in parallel. It's not like one computer is handling all this traffic. Each node, each representative node, has a bunch of actual different computers backing them. So we'll be processing lots and lots of transactions in parallel.
I just realized there could be an echo, Roy, with the way that this is working. I apologize to anyone that has that echo. It might be. I'm not sure if it's on my side or if it's on Roy's, but we'll take a look and try and get it fixed.
All right, we're starting to see an uptick in traffic now. It's a bit of an echo. So
Yeah, Roy, I'm just going to mute my mic while you're speaking, so that way it's no echo.
all right. Yeah, I'm looking at the stats here. So delay in getting stats out. Yeah, if you want to talk through anything while we're ramping up the load, but yeah, that's kind of what's happening now. It's just we're generating more and more traffic, try and scale up the entire process.
Roy, maybe you can talk about the regions and why we did the parameters that we did. I know there's a couple people in the community that mentioned the number of nodes and how that's historically relevant to other blockchains, but I know it's less relevant to us, and we've discussed it in Discord. But maybe it's important to kind of explain to everyone why that's the case.
Yeah, so the regions we picked are just sort of what we had already for the test network. We did move some things around last night to use some like more idle regions. Since this is a synthetic benchmark, we didn't request that our partners buy additional resources since we're just going to be generating this traffic for a short time. So because we wanted this to be temporary, we we moved things around to just where we had the most excess capacity within Google Cloud. So that's why we picked the regions. They're kind of arbitrary. They would affect latency in general, because you need to reach quorum from 2/3 plus one of the voting power of the network. So if the weight were more distributed, it wouldn't change our throughput. It would change our latency and reaching finality, just because you might need to travel at the speed of light to get some votes from far away representatives if they happen to be required for quorum. So the regions we picked were kind of arbitrary and not like, and we also the count 4, that was just enough to get us started and show that there can be more representatives than one. It can distribute up and scale up and down. In general, I think a well-distributed system will probably have like 16 representatives that have enough to reach quorum. So it's not going to be a very significantly different number than we have now. Let's see how we're doing here. Up to
We're closing in on the million mark here.
Yeah, so we're just ramping up the load and generating more and more traffic. It's all of the transactions, because they're from separate accounts, are getting processed in parallel. They're getting split up into requests to the representatives for votes. Those requests go to Google Cloud Run workers, and as more and more workers are needed, it's sort of similar to Kubernetes. It'll spin up more and more instances to handle the traffic, and then the traffic gets committed to the database backend, which is also done in parallel. We're using Google Cloud Spanner, which is by far one of the most scalable database backends we've used. We also we support a modular approach to whatever database backend we want to do. So this combination of Google Cloud Run and Google Cloud Spanner works really well for this, but the software is modular and can support other configurations as well. We initially ran it in AWS using AWS Lambda and DynamoDB. We were able to work closely with Google and make this integration a lot more performant and handling a lot larger transactions as well.
And one thing I just wanted to kind of talk about is what people are seeing in the chart here exactly. So let me just scroll down a little bit here. Try and include some of the stats. Uh, uh, so the bottom chart there is our stats API. That's us actually reaching the server in real time, grabbing uh, what is the latest counts. So the blocks, the transactions, and the response time in the top right is the response time of the stats. So that's the chart that everyone sees on the bottom, and then on the left is our blocks per second. Those are the blocks that are going across all the workers, as Roy spoke about, and the transactions are the operations within the block. Um, Roy, do you want to talk about the block structure for this test?
Sure. I think the layout that we're using here is with 750 transactions per block and one block per vote staple. So that's kind of organized in a way to minimize the cost for this demonstration, but also to show the flexibility of how you can, perform many different transactions in a single atomic unit of work. It would be, equivalent to do 750 transactions in 750 blocks with one transaction per block, and getting votes on those 750 blocks at the same time. The same amount of database work would need to get done, except for some more blocks getting inserted, and the cost would just be a little bit higher because of verifying all of the additional digital signatures. But all of the blocks and all of the transactions and all the blocks in a vote staple are all um, done atomically. So that's sort of what the unit of work is a vote staple, and that contains, you know, an atomic transaction that's being committed to the database backend.
One of the things I haven't really talked enough about. I mean, we've spoke about it a little bit, but um, is just the flexibility of our blocks. So the operations we're using today um, are just one of many things that you can do within a block. So you can create, for example, a new asset. You can send that asset. You can change permissions. You can do many different things within the same block. And so having many operations within a block, or within within a block, and then having many blocks within a staple, as Roy said, increases the efficiency of the system itself. And you can think about that from like a traditional like cryptocurrency exchange, where maybe they're processing withdrawals in batches. They can send transactions all in one block every second or something, instead of having to issue individual blocks, which just ultimately picks things up. Roy, we do have a lot of kind of jumping on the chart right now. Do you want to talk about why that is?
Yeah, I mean, it's hard to say why the jumping is happening in particular because the traffic is being done, by lots of different systems. They take some time to generate blocks and send them out, so sometimes they'll just hit a lull. Um, some of it comes from the stats time creeping up. It's hard to see in the chart because there was some slower stats, but the blue um, number indicates the back end time for fetching the stats. And so if that gets delayed, and then the chart will, you know, show a bunch of them happening all at the same time because it's fetching that data like at a delayed interval. So there's a couple of different reasons. One is the organic traffic, and the second is because it takes some time to fetch those stats, and as the load increases, then the time to fetch those statistics increases as well in some cases. But that's also pretty normal. The back end scale needs to scale up in some cases as well. So there might be a time where some of the data happens to get delayed while waiting for the back end database to scale up as it needs to reach this very high rate of throughput with a bunch of like random data being put into it.
Yeah, I don't know if anyone remembers, but on our initial stress test video that we released on YouTube from 2022, Ryan, one of our engineers, was kind of explaining that in that as well. So you're seeing very similar reaction to the system, and that is the flexibility of the system, kind of scaling up and scaling down. Um, it is very different than a traditional blockchain where you have one singular node that's just vertically scaling as a large instance. And so the reactive nature of ours is one of the unique properties that we have. Um, and as part of that, obviously, it does take a little bit of time. I think, Roy, correct me if I'm wrong, but I believe some of the workers take around 200 to 500 milliseconds for Cloud Run to start kicking in. Is that correct?
I mean, it can vary because there's a lot of things that need to happen on startup. So yeah, the amount of startup time is probably closer to 5 seconds, but each worker is able to handle, multiple requests, and then we're able to spin up a bunch of extra workers. But it does take some amount of time for the actual work to get processed. So just that increases the latency, which then increases the way the stats are measured. But it's in an organic environment where you were just processing a steady state of transactions with a few bursts here and there. That's how things would happen anyway, and you might have some cases where things are delayed. And in the back end, we're logging, a lot of information about how long every part of the process takes, so we can, look for any problems later on.
It looks like we're closing in
All right.
here on 6 million.
Yeah, I was just gonna say we're about halfway through the amount of traffic we're generating. So our target is generate 10 million transactions per second. So we can scale the system, larger and larger, and pay for that bandwidth and pay for different configurations. But for this particular test, we're just targeting 10 million. So we're about halfway with the amount of traffic we're going to generate for this test. And then once it reaches 10 million, it'll probably level off and stay there for a couple of minutes and then drop back down, just because uh, we're not starting all of the work at the same time. So by the time, some of the transaction or some of the sending parties, the sending clients get started, so the other ones will be ready to be finished just sending their predetermined number of blocks. See. We also keep track of the latency. So they're not, I guess, not displayed on this dashboard. But we do keep track of the latency for how long these transactions will take. So when this test is done, we're going to take a look at, what the average request time is for votes, average request time for publishing or adding to the ledger. And so we'll also have like the P50, P99, or P95 information from that. So we'll potentially display that information in the stats in the future, but I don't think that's published at the moment.
Yeah, I think we had it on the old dashboard, but I don't think we have it on this one.
We're at about 6 million TPS now. So just going up. There's not a lot more to say about the process, I think, but this is just how scalable the Keeta network is. It's scalable in the same way other, large systems are. It's built off of all of the same web technologies that make, things like Google.com and Amazon.com able to handle your queries. And so there's a lot of work from everyone in the internet community that we're leveraging here to be able to achieve this. So you know it's a high scale infrastructure project. So we're definitely lucky to be working with partners and able to bring this out.
Yeah, one of the things that I would like to do, Roy, is just highlight ChainSpect. They've been great at adding support for Keeta early. Typically, the way that their system worked is they'd only added it for mainnet, and so they actually made some adjustments to add tagging on the network. So now they can add support for testnet as we have today, and then once we get to mainnet, we'll have the mainnet added there as well. It is worth noting that the testnet and mainnet, from a functionality perspective, are basically the same. So we won't really see much of a difference. The biggest difference is that in the testnet today, the Keeta team is paying for all the transactions, so we don't have fee blocks attached. But when we get to mainnet, we will be charging fees. Unfortunately, as much as I would love to subsidize the transactions, they would be a little too expensive. So we'll have the fee blocks added, and that's the main change when we go into mainnet. But it looks like we just hit 7.8 million, and it's bouncing a little around here. So hopefully here in a little bit, as we keep ramping up, we'll get closer towards that 10. But
Yeah, 10 million is a lot of work for everything to do. So it just takes time to generate. It takes a significant amount of time just to generate the traffic. So
Roy, do we have, I don't know if we have the numbers on top of our head, but just I think it's worth explaining the magnitude of the data and the things that are occurring behind the scenes. I think that was one of the main things that we haven't really discussed, is just um, why it takes long to do one of these tests, and what is actually required from the database perspective, and from Cloud Run perspective, and I ultimately why we can't do it without the collaboration of the Google team. So I know some of you guys are watching. I appreciate you guys, all the work you've done to help us get here. But Roy, do you want to kind of highlight that?
sure, yeah. There's each block contains a bunch of transactions, and that's a lot of data that needs to then affect the accounts in the ledger on the database. So as the transactions come in, it needs to be able to do that work in parallel successfully and atomically, which is a significant amount of work. But yeah, there's a lot of technologies like in Google Cloud Spanner to handle the back end part of that, but also the Google Cloud Run, which is very similar to Kubernetes, allows you to split up the computing part. So as long as the process is parallelizable throughout the computing and the storage, and from the client's perspective end to end, then we're going to be able to increase the number of systems in the process of doing that. So this will put around 4 GB per second of read and write combined throughput from each of the nodes representative, each of their Cloud Run instances, all of them combined, which there's, I think, about 20 to 30,000 at this point. Each of them is putting a combined read and write load of about 4 GB per second into their respective databases. In this case, Google Cloud Spanner.
Roy, we just passed 10 million.
It's still going up. Like, the main thing to keep in mind is sort of the average line going through. There might be like a spike that goes through 10 million, but we want the average to be above it just to smooth out any of the statistics. So it should keep going up for just a little bit longer and then stay, have an average above 10 million. So, as the work continues on, it has to keep all of this data not only going to the database, but the database has to keep it consistent and atomically adjusted. So that's quite a lot of work, right, to make sure that all the accounts are ordered and all of the constraints are validated every time. So yeah, it's definitely a lot of engineering effort that's gone into everything that you see here.
One thing, and this is not really necessarily the format to just address everyone's claims, but one thing I did see this morning, Roy, on Reddit, someone made a comment about the fact that we're using centralized hardware or non-consumer hardware makes this endeavor easy. Obviously, you and I and the rest of the team know that that's not true, but I don't know if there's anything you wanted to talk about there, and the complexity as you just highlighted that actually got us here. It was a lot of work around coordinating not only just the data but also being able to. I think on the processing front, on the Cloud Run, there's a lot of things that we've had to do there that ultimately wouldn't be available on other networks. I think the stateless nature of our nodes is probably one of the more complicated things that people look over, and I'd like to highlight that.
Yeah, I mean, the difficulty is in the architecture, not this. I mean, there's a lot of difficulty in the implementation as well, but like the difficulty of ensuring that the system can scale while being consistent is in the architecture. So yeah, we definitely put a lot of thought into making sure that the system is parallelizable end to end. That's why there's no mempools or other asynchronous things that require some centralized coordinator for each node. Right, each node would need some way to centrally manage that stuff, which makes it hard to be distributed internally. So yeah, we did put a lot of effort into thinking about how things were done, would be done before doing them.
One thing I just wanted to highlight, we did see a pretty big spike on the stats there. That was some of the jumping we saw on the chart just a little bit ago. If anyone noticed that and was wondering what it was, but it looks to be it kind of calmed back down. So we're hovering here, around the 10 million mark. We're going over it a little bit as we scale up. But Roy, do you know from a percentage wise how close we are here?
Yeah, I think we're about at our target. So it should start to hover around 10 million give or take right now. So that's what we're aiming for. So it should just continuously stay here around 10 million for a little bit and then start to drop down. Yeah, one of the difficult things is in measuring the throughput at this rate. So that's why it's a little also, that contributes to the noise is, how do you actually construct a fast enough counting system that, as you're doing 10 million things from 30,000 systems in parallel, that you're able to account for that rate. So the statistics are, also like doing the work of maintaining the statistics also takes an amount of work, right? So everything involved has an accounting associated with it, and that goes into the cost per transaction. And so the efficiency of the process overall, leads to lower cost per transaction.
I must say I'm a lot happier right now than what I was 30 minutes ago. I was definitely nervous, but just want to say congratulations to everyone on the team, and um, thank you for all the work you guys have done and the long nights leading up to this. Um, this is really one of the largest moments in the company's history, and I'm glad that we get to share it with the community now. But I just I know that everyone has put a lot of time into this, and we should all cherish this moment with everyone in the community. So thank you all, Roy and the rest of the team. I know there's some people on the Zoom call here. I don't know if you want to say anything, but if you do, feel free.
I mean, yeah, like um, primarily me and Ty speak during public events, but there's um, lots of people on the team working tirelessly, especially lately, to make sure that we're able to meet all of the things we have with the community and with our partners. So yeah, it's a lot of work, um, just to make sure that everybody is able to you know deliver everything. Yeah, one thing that's to note about the statistics is because you're looking at snapshots of the time. What you see, um, what you see on your view of the Explorer may be different than what somebody else sees because they're looking at a different snapshot.
Roy, do
So
you want to just highlight real quickly the issue behind the Block Explorer? I know there were some concerns earlier this week with it being down or being intermittent, I guess. Do you want to just highlight why that was and how it was not related to the network?
yeah, the Explorer was having problems earlier because of um, some internal networking issues we were having with the way that the back end of the Explorer, which talks to the network, was configured. So it was using something called network address translation, and the system it was going through just didn't have enough resources to handle all of the stats requests that the Explorer was doing, other kinds of things. But so it was just running out of resources trying to connect to the network behind the scenes. So we re-architected that so it wasn't using the network address translation, and yeah, things were a lot happier after that.
Amazing. Looks like we might have jumped over to 12 um, briefly here as things are still bouncing around. Um, our response time on the stats is also quite high right now. The system's um, definitely dealing with a lot of throughput. So, um,
Yeah, yeah, we're reaching about what we've configured as the maximum rate for this test. So There's different bottlenecks. The Spanner, Google Cloud Spanner as our database is one, but we're also using Redis for statistics and things like that. And so we configured enough resources to hit about 10 million TPS, and we're on where statistics are stored. That includes the Redis configuration, and we're reaching about 100% of the Redis configuration right now. So stats are going to go up, but also, because we use Redis for other things, we're going to be decreasing the amount of transactions to kind of reach equilibrium around 10 million. And then stats will go obviously down as things settle in. And let's see, we are just about at 30,000 Cloud Run workers. So there's 4 rep for the representatives involved. So each one is, doing some amount of, 1/30,000th of the work of this test. And then there's 4 nodes, so that's multiplied by 4. So it's quite a lot of, compute power and engineering effort that's backing this up. But here we are, around 10 million TPS as expected.
Roy, do you want?
Should start to peter off here, and then should start to go down in just a couple of minutes.
Roy, do you want to just highlight the importance of 10 million? I know I've spoke about it a lot extensively, but why we wanted to get to this number and how it translates to, I think most people are aware, but how it translates to blockchain and the history of distributed systems like this.
Yeah, so Keeta's goal is to be able to power all of global finance, and 10 million is a nice round number that kind of aligns with that goal of 10 million transactions per second is certainly more than happens globally right now. We wanted to make sure that we were able to scale up linearly to not just 1,000 transactions per second, and then you're stuck and not able to grow the system more, which could limit the usefulness of the system in the future. Not just 10,000, not just 100,000, but basically no limit. And so 10 million is kind of what we settled on as a benchmark for verifying that we can scale linearly. So if we can do 10 million, we can do 100 million or, 1 billion transactions per second if we're willing to put in the work and the effort to pay for those. And, in the future, that might be necessary and worth it to do. So that's something we definitely like put into how we thought about this and how we thought about what our benchmark number should be.
Yeah, the one thing I just want to highlight or reiterate is that the system from an architecture standpoint and implementation standpoint, although the implementation, to be clear, might need some improvements as we get up, but from architecture standpoint, it's entirely unbounded. So, as Roy said, the amount of hardware and the cost is the only limitation, and in this particular scenario, obviously we wanted to hit 10, but if we wanted to pay for it, we could certainly do significantly more. And like I said, from the implementation standpoint, we might need to do some testing to scale up. At 100 million TPS, do we hit a couple bottlenecks that maybe we didn't at 10? But overall, we've built methodically to scale with the resources available. We have a couple of things that we've worked on internally in the past that kind of works around some of the hardware um, and how we can create those larger systems. But right now, obviously, we're working with Google Cloud, so everything's hosted on Google Cloud. But we can also run things on your own hardware. If you had like a Kubernetes setup on your own hardware as an FI, you can have very similar results, and you can participate in the system. It is also worth noting that this is a little bit of a difference from other networks where they run on smaller hardware, maybe hosted at your home or things like that. As Roy highlighted earlier, the sheer data throughput just is not feasible to be on a residential connection. So we do need a larger kind of hosting setup. That doesn't necessarily mean that you can't be decentralized. You can still host your hardware wherever you would like, and the ownership of the decentralization, I think, is what's really important there. But yeah, it's definitely a little bit more of a beast to operate than the normal blockchain nodes.
Yeah, I mean, you could still run a network, entirely off of consumer hardware. It would just be limited to those resources. So whatever resources you have, they can be used. You could run the node on your phone if you wanted to, but it doesn't necessarily mean it's a good idea, and probably people wouldn't want that to be their representative on the network.
On our network, it is worth noting, since I know the centralization point is something that's brought up a lot with regards to Keeta. We are going to have certificates attached on chain for all the reps, so you will know who's going to be operating that rep, and I think that is one of the many attributes where we can kind of counter the decentralization point, and we can be equally, if not more, decentralized from an ownership perspective than other networks. A lot of networks operate on kind of cloud hosting. Ethereum, for example, is predominantly AWS behind the scenes. Bitcoin's obviously geographically centralized based on the manufacturers of the miners. So there's a lot that goes into the decentralization, but I think we've been pretty thoughtful about striking a balance in from a product standpoint of what is required in the industry and what's still practical. So I'm very, very proud of the work we've done on this front.
Yeah, and so like I mentioned earlier, things are going to start to level off and come back down right now. So we're just sort of in a holding pattern as more and more blocks and more transactions get generated. I think we've done more transactions today than most networks will ever do in their lifetime. We're at almost 18 billion transactions on just past 18 billion on the test network.
Roy, we've done more per second than some networks may do in their lifetime. I will say, though, with that said, even though obviously our TPS and our throughput and our performance are very impressive, and it's kind of the leading topic of Keeta, while everyone's here, it is also worth noting that there are many other features that I think are probably equally, if not more important than the throughput, such as built-in compliance with KYC certificates. We have very extensive permissioning system. Things like joint accounts can exist, or delegated access to accounts. There's different transaction rules you can set on when you create a token. such as what accounts do you want to allow or not allow. Do you want the token to be sent to only people of a specific certificate or a specific attribute within a certificate? There's a lot that you can do, and I think one of the things that I speak to quite often privately is the use case around Swift. When there's a global or geopolitical conflict, those networks are usually very binary. They say, okay, we're going to take this action, we're going to cut you off completely. And that's the public statement. And then behind the scenes, they kind of have to pull that back a little bit because they still need to transact in specific use cases. And so Keeta is built for that use case specifically, where we can, come together as a community. Obviously, if it's decentralized and there's not enough quorum, then it doesn't happen. But from a specific token, let's say a digital dollar, the issuer of the digital dollar can say, I only want this dollar to be used for these particular purposes with these accounts. And you have that control. So you don't need the binary action of just cutting someone off from a system entirely. So it's not just our throughput, but all the functionality and all of the thoughts that we've put in from a product standpoint to make this actually a practical option, and likely what I believe is the only option as of today to handle the CBDCs and the tokenization of real world assets and global finance. So I appreciate everyone here witnessing this. Roy, we've got about 1,500 people. I think we had over 2,000 a little bit ago. So we definitely have quite a few people watching this in real time. And I thank everyone for being here.
Yeah. Well, so on the backend database, we're up to 5.4 terabytes of data now stored from this test. Before we started, we had on the test network about 800 gigabytes. We've done about 5 terabytes of ledger stored data. It's going to be larger than what's transmitted, but because that's compressed and that has less denormalization applied, so the ledger needs to denormalize things a little bit to be able to quickly access things. So in the back end now, we're storing an additional basically 4.5 to 5 terabytes so far.
Roy, I just wanted to show you one thing. I still have the original sketchbook that we purchased at Target in 2022 with our ideas on the system. And one of the things that I look at a lot on here that you drew is, if I can pull it up, is around our checkpoints. I don't know if it would go on camera or not. Yeah, it's hard to, with my background, it's hard to have it on camera. But we have a checkpoint system and a pruning system that kind of address the large amount of data that you just highlighted. I know that's not in production or on testnet or anything today, but can you talk about why that is important?
Yeah, so representatives need to charge people at the time of transaction for the ledgering of that transaction essentially forever. But it's not really like a computable cost. So for many cases, it's possible to get rid of, on the representative side, to get rid of older data because you can always re-verify it later as long as you have the hash of the head block. So it's possible to sort of reduce the amount of data stored over time in many cases by offloading that work of storage to historical nodes. They don't need to be as performant. They just need to store data. So we can kind of bifurcate how the system works so that there's the storage nodes are the archival nodes are doing the archiving at whatever rate that they can, but the representatives are keeping track of the live data as fast as they can, and so that allows us to reduce the cost even further of transactions because uh, the representatives aren't having to pay for storing every transaction forever on every representative. As long as they can get that data from a validator node, they can know that they've already processed it, and they can because it's a block, because it's a chain, they can know that they already have access to that data and don't need to do a bunch of work to revalidate it. So as time goes on, they don't have to pay for the storage cost redundantly. That can be something centrally managed on the network, or uh, as a function of users who have storage instead of compute
One
and
thing I,
bandwidth.
not to interrupt you, one thing I just also see here that we should highlight are the different kinds of nodes that you can, or the different modes that you can put the node in, rather. So, as you said, the reps can go into kind of a voting only mode, which would be, is it head plus one, or is it just head block? I think it's head plus one, right?
I mean, it, it's not implemented right now, so that's not decided, but it can be a lot of different um, options. You could store as little or as much as you want, as long as you have a way to verify it. You could run a node that only has the accounts you care about data,
Yeah,
right?
such as an
Or you could run an
exchange.
archive. Yeah. Or you could run an archival node, or you could, have it vary depending on whatever your particular needs are for that kind of node. So an archival node would keep track of every block forever. Um, but it's going to be doing that as fast as it can and as fast as it can verify. So it may not, always be the most up to date. So if you're not running an archival node, you may say, "Hey, I want to keep the last 10 blocks, and then because I trust the archival node will be, relatively up to date," or I want to keep 100 blocks because the archival nodes that I know about are generally behind. And and you're able to do that. And if you don't have some blocks, you can reach out to other participants on the network as well and request them and see if they have them. So other representatives might have different configurations, or other nodes might have them. So as you're working on maintain, if you did want a historical block for some reason, you would configure that based on whatever your particular needs are for this node that you're running. And then representatives, the main thing that they care about is their votes and the votes they issued, as well as not issuing competing votes. So they need to maintain um, pretty much what the head blocks are, so that they can ensure that they're doing that. So the cost of creating a new account may be different than the cost of um, adding new blocks to an existing account, because you ultimately have a certain amount of data that you have to preserve as a representative for every new account. So establishing an account, and because the representatives can charge whatever fees they want for the blocks that are the operations that are in the blocks they receive. So they can, if you're doing something that's going to cost them more, like opening a new account, they can charge you more to make up for that, knowing that they're going to have, to pay a fixed cost for the lifetime of that ledger. Let's see. Let's check on
Oh,
the
I
Explorer.
was just muted. Sorry. What I was going to say is, as we see here, we're definitely hovering around the 10 million plus mark. We've gone up to 12 a couple of times. 14, we had a jump, but well beyond 10 as an average. Um, and yeah, this is very good moment for us right now. So I'm trying to not celebrate too much, but I'm definitely very happy right now. So Thank you guys, everyone on the team that put the work in here to make this happen.
Yeah, I'm not sure if there's anything else we want to go over, but
I think that's it. I
but,
think we've covered most of things. I don't know if there's anything you want to necessarily talk about, but I just want to remind everyone that is here. You can join our Discord, and that's where we try and answer as many questions as we can. Obviously, we have multiple different things going on at the same time, so sometimes it takes long. Our moderation team and the rest of the community will also try and help and answer any questions, but we also do Twitter Spaces every Wednesday. Sometimes we have to skip if I'm traveling or something, but try and do it every Wednesday at the same time as this, and you can go and answer questions or ask questions there as well. So yeah, I appreciate everyone here, and Roy, I don't know if there's anything you want to talk about before we wrap it up here, but we're coming up on the hour.
no, I think that's it. I think the target was 10 million. We provisioned the resources for doing a little bit over 10 million, and that's kind of what we see as things approach our configured resource limits. That's where the sending side starts to run out and self-regulate down into the amount of resources the network has been given. If we wanted to give it more resources and pay for that in the future for some reason, we could also do that like that. I think that's sort of the goal here, is to demonstrate that we can scale up to meet the demands of all of global finance today, tomorrow, and next year.
Amazing. With that, we're going to close this off. I will also say, please follow us on X, Keeta, at Keeta Network. That's where we post a lot of our updates as well. Gabe does a lot of threads in depth about the different attributes on our system. So some of the documentation there is also really helpful if you go there and kind of read. We also have docs.keeta.com, which currently is a little high level. We're working to expand that. Mark and Gabe and the rest of the team are working to expand that to include some developer documentation, and it'll be eventually more in depth to kind of explain each concept from both start the conceptual point and then work down into how do you practically interact from a developer perspective. So we're working on a lot of things behind the scenes, and yeah, I'm excited to just keep executing on our vision and keep delivering for the community. So thank you all. This is where we'll wrap it up. If you guys are watching independently on the Block Explorer, you'll probably see transactions will continue to kind of work their way back down here as they already are, and we will hit. I believe we've been kind of hovering at a few thousand TPS, kind of consistently outside of our traffic. So feel free to go to our documentation and start using our SDK and interact with it. We also have Wallet and a faucet that kind of helps you send things around. So if you wanted to test out creating a token, you can do that in our wallet pretty easily. It takes you maybe 30 seconds or so. But that's all for today. Thank you all. Appreciate it.
Thanks, guys.